Respected Chairperson, Reporter, and my dear colleagues. I am T Nagaraj, Senior Geologist working in Engineering Geology Division, Southern Region, Hyderabad. Now I will be discussing something about the construction stage geotechnical investigation of a reservoir project named Gottimukkala, which forms a part of the Dindi lift irrigation scheme. Actually, this is the scheme. This is foreshore of Srisalam reservoir, and from here water will be tapped, and then this is 325 level. Here water will be lifted to a height of about 80 to 90 meters, and it will be allowed to flow to fill all these reservoirs en route, and the first being the Singarajpal reservoir, and there lies our Gottimukkala reservoir, which is fourth in the row, through a canal system which is 59 kilometer long and 22 meters having a base width. Actually, there are 7 reservoirs along the flow direction, that are Singarajpalli, Erapalli, Gokavaram, Irvin reservoir, and this is the one which I will be discussing something about. Actually, the scheme involves drawing of water and letting into the approach channel and through a 10-meter dia tunnel, and finally that will reach the Ulpara barrage, and then from there on, this en route all the reservoirs will be filled up. So this is actually a scheme, and this is from where the water will be lifted and allowed to flow through the canal. First, this is Singarajpalli. Then comes actually 7 reservoirs. This is old map and all. So ours is the fourth in the row. So this will be the Gottimukkala reservoir about which we are talking about. So this is a 18.6 meter high and 3850 meter long reservoir with a 5-gated spillway with 6 blocks and all. And it's an offline reservoir which will be filled by this Dindi main canal through a 13 kilometer long offline approach channel. So for which construction stage geotechnical investigations were carried out by me on 1:100 and 1:200 scale. 1:100 for gravity structure and 1:200 scale for cut-off trench, earth dam. So this project is situated almost 0.3 kilometers west of Gottimukkala village. This is the location map. This is the Gottimukkala site, and this is the dam site. It is having 2 kinks. One is near the one local Bhimapalli Vagu, and this is other kink. This is 3850 meters chainage. So the salient features of the project are: height is this much, T-bale is 344, FR is 340. It's having a storage capacity of 1.839. So previously systematic mapping were carried out by our own GSI officers, and this is almost some LS of the dam, earth dam. I am talking about earth dam now. Then I will come to gravity structure later. This is again the contour plan wherein the dam alignment is shown here. Regarding geomorphology, it is the Bhimapalli Vagu, which is a hill stream and all. It is the main contributing factor for this earth dam. Regionally, the RVARs of PGC to paleopatric age, they contribute and all. But at the dam site, it is coarse-grained grey granites of PGC are exposed on the foundations. Then comes, this is geological map of the area. This is our dam, which mostly runs in the pink granites and grey granites also. So first, geotechnical assessment was done from chain 342 to 1938, leaving a gap of 100 meters for the gravity structure to be built, that is 5-gated spillway, and again 2038 to 3.7, where this will be the end of the dam, this one. So as to bring about the weathering profile and bedrock characteristics and all, 3D geological mapping of the earth dam or the excavated cut-off trench was carried out in 2 reaches, left and right flanks on 200 scale. This is one of the maps wherein you will have thin overburden, say 0.3 to 1.2 meters, followed by highly weathered bedrock, and this is moderately weathered and hard granite. here and there you will be finding sheet rock. This is a light pink color. So about 5.2 to 10.1 meter of excavation was required to reach the acceptable foundation grade. But however, in some of the reaches, fresh rock was exposed. These are the reaches wherein fresh rock was exposed. Along these two reaches of the earth dam, almost 35 meter, now 75 to south 70 east ending dike was intercepted. So also a 9 meter wide dike again got intercepted, and the litho contact, which when I observed it was sharp, showing some staining effects, but lot of fracturing and fissuring was seen. This is one of this thing. And also, because of weathering phenomenon and movement of groundwater, I think lime contour bands or calcite bands of say 5 to 15 centimeter wide was seen to travel across and along the bedrock, and mostly when I observed during mapping and all, they were confined to highly weathered sections only, mostly. And bouldery granite was also present very rarely and all. The conical projections also were present along the floor of the cutoff trench, which was suggested to be removed to develop a smooth rolling and compaction of the strata. The foundation media is traversed by 4 to 5 sets of joints which are vertical to subvertical and then close to widely closed space. They are generally tight and discontinuous. Aperture were also seen at some places, but generally the joint system or joint sets were askew to the dam axis, except the north-south trending joints which are almost parallel to the dam alignment, sir. So, in order to have a clear picture of the bedrock condition and the permeability of the bedrock, I have suggested permeability to be conducted in these reaches. Almost every 100 meter, one permeability hole, and also wherever there is some problem or say in dike transmitted reaches. These tests were conducted from the final bed level of the floor level of the cutoff trench, okay, and were suggested to be conducted for depth of 9 to 21 meters for taking every 3 meter test section, and also applying 0.5 to 2 kg per centimeter square in consonance with the height of water column at that particular level. The data shows that the Lugian value of the permeability of that bedrock varies from 2.7 to 25.8. 2.7, the minimum permeability what I got was in the deepest sections, where generally fresh rock will be encountering, sir. And the maximum value will be top 3 meter section, where a lot of blasting and excavation process is involved. So finally, the recommendations I have given for the cutoff trench or for the earth dam was to knock out some projections appearing here and there, and to finally to conduct, to provide a grout curtain to a depth varying from 3 to 9 meters and also 3 to 6 meters in particular changes wherever the geology was different and all. So, and also depending upon the water column, how the recommendations were given was, one is lithology, orientation of joint sets or structural continuities with respect to the orientation of the dam alignment, and also height of water column. These are the factors that were considered to suggest some recommendations. And finally, before filling this thing with hearting soils, it was supposed to be cleaned thoroughly. Okay, sir. This is something about the earth dam. Now coming on to gravity structure, that is spillway, 5-gate spillway. These are the blocks. It was located across Bhimapalli Vagu, which I showed just now. It is a 110 meter long spillway with 6 blocks, block 1, 2, 3, 4, 5, 6 and all. 1 second, sir. The spillway is 110 meter long. It is constructed across east-west trending Bhimapalli Vagu. And for that, 10 boreholes, subsurface exploration was done by drilling 10 boreholes, which were logged by me, and the thickness of each is mentioned here, and the depth to bedrock, that is granite, was varying from 7.5 to 9 meters. Okay, sir. This geological section that was prepared, wherein this is a overburden, highly weathered bed rock, and also moderate weather, there is fresh rock. So the core recovery percentage was also calculated 75 to 92, and initially it was suggested based upon borehole drilling data and all, it was suggested to excavate the foundations first to a depth of 7 meters below ground level for further assessment. And also, this is one of the block 4, 5, 6 geological mapping was carried out. So there you can see some acidic quartz veins, these things, this highly weathered bedrock and all. The entire thing is granite. So it necessitated 9.5 to 11.5 meter depth of excavation to reach the present level of foundation grade. Okay, sir. And again, this is same set of joints which I got encountered in the earth dam section, repeated same, and permeability was conducted again almost in every block for every 20-25 meters. So there, up to a depth of 18 meters, I got tested the permeability of the bedrock with applied pressures of 1.5 to 2.5 kg. Why? Because our earth dam maximum section is there only, 18.75 meters. That is why I have suggested 1.5 to 2.5 kg per centimeter square pressures to be applied. Suppose if you apply more pressure and all, the joints will get opened up. This was the theme behind telling all these things. So finally, the test results showed that the Luggian or permeability value of the bedrock in this gravity section ranged from 17.7 to 33 because of blasting operations and all. So finally, recommendations for spillway was given like this, sir. To remove overhangs, so many overhangs were found because of blasting and all. So, and lot of curvilinear joints were there which were very smooth and all. So they were suggested to be roughened up. Then sloping, sir. Then finally, to provide consolidation grouting in the body wall portion, starting from the spillway axis, up to a depth of 12 meters was suggested at a spacing of 3 meters to seal off all the pervious or open jointed zones. And also finally, not satisfying with this one, post grouting permeability was also suggested to have a better understanding of the bedrock. And recently when I went to the project and all, I inquired about the post grouting permeability, how it was. They said it is 1 Luggian or even less than 1 Luggian, which was quite satisfactory, and I felt very happy because they have followed our suggestions and did the permeability and other things very correctly in a systematic and scientific fashion, sir. Okay, sir. Thank you. These are some of the photographs, sir.
Thank you, Mr. Nagaraj.
Yes, sir.